Okay, so our first topic is how circadian rhythms can affect hypocotyl elongation. And our group members are David Huang, Ibo Shi, and Yuchen Liu. So our first topic will focus on the general pathway of PIP proteins, which we have taught during the lectures. And for the general PIP pathway, the PIP is degraded by the phytochrome or by the active phytochrome. The phytochrome will be active when we shine red light on them, and they will be inactive when shine the far red light on them. And after they're active, they'll enter the nucleus uh, to bind to the PIP pathway, to bind to the PIP protein, which is here. And the active phytochrome will act as a E3 ubiquitin ligase. It will add the ubiquitin proteins on them, on the PIP protein. And after that, well, the PIP protein with ubiquitins on them will be transported to the proteasome for degradation. So the PIP pathway, the PIP protein will not will be degraded, and the expression in controls will be inactive. And during the in the article we chose, they briefly talked about the two proteins, the PIP4 and PIP5, and they in the single mutant they see the PIP4 plants has some growth, and in the same situations are observed in the PIP5 single mutant as well. But in the double mutant, there's no growth, which means the PIP4 and PIP5 are significant for the plant growth. But also the PIP4 and PIP5, they're redundant to each other. And the top figure over here is talks about the protein levels for PIP4 and PIP5. We can observe that when there's light, the protein levels decrease dramatically. And when there's dark, when we're in a dark environment, the protein levels will increase dramatically or instantly, which means the mRNA levels are also correspond to what we observe in the protein levels. It's right here in the bottom figure. So the author proposed a figure to illustrate the whole pathway. From in the day, there's no PIP4 and PIP5 expression, and in the early night, there's no PIP4 and PIP5 expression. But in the late night, there's expression for both proteins, and there's hypocotyl elongation. This is basically the way they find the wild-type siblings, which led us to the following studies.
So after we discuss about the PIP protein functions, so we are looking into what it forms the circadian rhythm in the hypocotyl tissue. So in the lecture, we introduced one of the mutants, which is HY1. It's always shows thin elongation in no matter in the light or in the dark. So the scientists also discovered another protein, which is ERF3-1. It shows similar phenotype, but after looking into the growth patterns of hypocotyl, it shows like the patterns remains in the HY1 mutants, but it doesn't exist in the ERF3-1 mutant, which indicate that the ERF3-1 is responsible for the circadian rhythm in the hypocotyl tissue. Next page. So in this article, scientists are able to identify some of the genes involving in this pathway. The first one is what we're really familiar with, the TOC1 proteins. It's involving the time of cap, which is phytochrome binding protein. And the second one is all these genes regulating by transcription of factors. And what is stands out to be most significant is LH1 and CCA1. These promoters control the mRNA level, which Ibo introduced in the last pathway, and the ELF3 protein is also in the downstream of the TOC1 proteins. Is control the plant circadian rhythm in the dark. So I'm passing to the next person.
So this is what the clock mutant looks like. Okay, next page. So people have this conclusion: the internal factor, circadian oscillator, and the external factor, light levels, they work together to influence the hypocotyl elongation. Next page. So we made this pathway. Okay, this is the pathway during the day. Circadian rhythms at this time help the plant to make PIF mRNA, which will then translate to PIF protein. However, with the presence of light, phytochromes will be activated. They phosphorylate and degrade all of the PIF protein. When that happens, they cannot undergo hypocotyl elongation. Next. In the early night, according to the circadian rhythm, this plant stop making PIF mRNA. No PIF protein will be translated and no hypocotyl elongation in the early night. Okay, next. However, when it comes to the late night, plants start to produce PIF mRNA and then translate to PIF protein. Without the light degradation, PIF protein can finally going to help hypocotyl elongation. So that's why we have this well-type figure. Okay. Thank you.
Here's our reference. Thank you for listening.